In the last few videos, we introduced algebraic expressions and we talked about writing algebraic expressions. In this video, we're going to talk about simplifying algebraic expressions. Now, if you'll recall from your knowledge of fractions, you'll remember that we can simplify fractions. So we might have a fraction like 2/4, but that's not a simplified fraction. To simplify this, we have to divide by 2 to get the fraction 1/2. And 1/2 is just the simplified form of 2/4. Likewise, 2x plus 4x is not a simplified expression. However, we don't simplify expressions in the same way we do fractions, so we don't do something like divide by 2 to get x plus 2x. That is not how we simplify expressions. To simplify expressions, we have to revisit something we talked about when we introduced algebraic expressions a few videos back, and we had the term, which is very punny, but so a term is a number or the product of a number in variables raised to powers. So the expression 2x plus 4x has two terms, one of them being 2x and the other being 4x, and they're separated by a plus sign. Now, if we want to simplify terms, we need to talk about like and unlike terms. So down here, you'll see that like terms are terms with the same variables raised to exactly the same powers. So again, with 2x and 4x, these are like terms because they have the same variable x and they're raised to the same power 1 here. And notice that the coefficients don't matter. They can be anything and still be like terms. Now let's do a few examples here to see if we can tell the difference between like and unlike terms. So here's the first one. 5y squared and 5y cubed. Are these like or unlike terms? So first we need to look at the variables and see that they are both y, so that checks out. But then if we look at the powers, this one is squared and this one is cubed. So they're raised to different powers, so these are unlike terms. Next one. ab cubed c squared and ab cubed c squared d. Now, of course, terms can have more than one variable, as is the case here. So these terms have three variables in powers that are the same, ab cubed c squared. But this term here has an extra variable d, so these are unlike terms. Last one of these examples. Y squared x and negative xy squared. So here the commutative property is being used because we have y squared here and y squared here and x here and x here. So these are just being written in a different order, but they have the same variables raised to the same powers. Even though this is a negative, the coefficients don't matter. So these are like terms. One way we can simplify algebraic expressions is by combining like terms. So with two like terms, again 2x and 4x, if we're adding these together, we want to combine these like terms, and we do that by adding the coefficients together and multiplying by x. So 2 plus 4 is 6, and then x. So 2x and 4x simplifies to 6x. This makes intuitive sense. If you think about it, x plus x we know is 2x, and that's just adding 1 and 1 to get 2x. So, but what are we really doing when we combine like terms? So, if you'll remember the distributive property, which I hope you do, we're just using the distributive property, but in reverse of what we did in the past. So, 2x plus 4x is really just quantity 2 plus 4 times x. And you can see we just, if we want to multiply this out, it'd be 2x then plus 4x, distributing the x over the thing. Or if we want to do by the order of operations and add inside parentheses first, 2 plus 4 equals 6, as I have there, times x. So you can see how we got the 6x from this expression up here. So that's how we can combine like terms to simplify expressions. Let's do some examples. First one says negative y plus 3y. So if we'd like to combine like terms here to simplify this expression, we simply have to add the coefficients of like terms and multiply that by the variable part. So we do have like terms here since we look at the y. 2y is here, same powers. So now we simply add the coefficients. So negative is just negative 1 plus 3, and then multiply that by the variable part y. So negative 1 plus 3 is 2y. Next one. 5x plus y minus 8x plus 5. So here we have an expression with more than two terms, which is perfectly legal. First, we have to identify the like terms. So we have 5x and negative 8x. I'm bringing the negative along there with the 8. So we combine these by adding together the coefficients. So 5 plus negative 8 is 5 minus 8 times x. Then drop down the y and the 5 there to rewrite it. 5 minus 8 is negative 3x plus y plus 5. So there's that, and moving on. Here we have, I'll scroll up here, 1/2 a squared b plus 1/4 ab squared plus 2 minus 3/2 a squared b plus 4 plus 7 over 4 ab squared plus 5ab. Alright, we've got a doozy here. But it shouldn't be too difficult if we just follow our procedure of combining like terms. So here, if you'll look here, we have three different sets of variables. So the first set we have here is, I'll underline this in black, a squared b. We have one a squared b there and another here. Then we have sets of ab squared, one there and another there. And then we have one ab all by itself, and then some coefficients as well. So we want to combine the like terms that we have here. But what will help us here is if we rewrite this expression to put the like terms next to each other, then that will make it easier for us to combine them in the next step. So I'll rewrite this here. 1/2 a squared b minus 3/2 a squared b. Add that to 1/4 ab squared plus 7/4 ab squared plus the 5ab, and then add that to the coefficients, which we can just take care of now. 2 plus 4 is 6. So now we combine these like terms. So just add together coefficients. 1/2 minus 3/2, and then we multiply that by a squared b, and then we do quantity 1/4 plus 7/4 times ab squared, and then throw these down here, 5ab plus 6. Now we just add inside the parentheses, or subtract in this case. 1/2 minus 3/2, just take the numerators. 1 minus 3 is negative 2 over 2 equals negative 1. So that's the coefficient. Negative a squared b. Over here we have 1/4 plus 7/4 is 8/4, which is 2. So that's our coefficient there, plus 2ab squared. And then just rewrite this down here. 5ab plus 6. And that is our simplified expression. Let's do another one. Negative 3 times the quantity m minus 2n plus 6. So in the past examples we had there, we simplified expressions by combining like terms. Another way of simplifying expressions is by using the distributive property to remove parentheses. Parentheses, which are like excessive number of terms, are what mathematicians consider to be not simple. So we have to simplify this expression, we have to get rid of the parentheses. So let's distribute the negative 3 over each term in the parentheses. So negative 3 times m plus negative 3 times negative 2n plus negative 3 times 6. Now we can just multiply these out to get negative 3m plus negative 3 times negative 2 is 6n minus 18 at the end there. So that's our simplified expression. Now last one. Alright, this expression we're going to have to use the distributive property twice. So we distribute 4 over each term in the parentheses here, so that's 4x plus 4 times 5 is 20 minus 2x squared is minus 2x squared minus 2 times x is minus 2x minus 2 times negative 6 is positive 12. So we've got that there. But if you look here, you'll notice that we still have some like terms lurking around, so we're going to have to combine those before we can go to the simplified. Here's the like terms, the x's here, 4x and negative 2x. So we'll just combine those. Well, first we can rewrite this. We'll put the negative 2x squared out in front, and then put the x's next to each other, 4x minus 2x, and then just take care of the coefficients now. 20 plus 12 equals 32. So add that on there, bring this down here. A lot of this is just rewriting, but now we come to the essential part. 4x minus 2x, add together coefficients. Here we don't, once you get good enough with these, you won't even have to do the parentheses. You can just say 4 minus 2 equals 2, so that's 2x, and then 32. And that's our simplified expression. So that's all I have for this video. I know we had a lot of examples here, but I hope this gave you a better understanding of simplifying algebraic expressions. In the next video, we'll actually be plugging in some numbers for the variables, and we'll call it evaluating expressions. So I'll see you then.